this cat is in a box. Probably you know the hypothetical example. It's in a box, and there's a killing mechanism which is triggered by a quantum event. And so the cat is shut up in the box, and you know that a quantum event might or might not have happened. So the cat might or may not be dead. According to the Copenhagen interpretation of quantum theory, the cat is neither alive nor dead until you open the box, and then suddenly it becomes either alive or dead. Well, Schrödinger proposed that as a way of ridiculing the whole idea of the Copenhagen interpretation. David Deutsch believes in the many worlds interpretation, which is that the world is constantly branching and producing new worlds, and there are many worlds in which the cat is alive and many worlds in which the cat is dead. And already in our particular world, the cat is either alive or dead, and we don't know until we open the box. But there are another millions of worlds in which the cat is alive or dead. By the way, there's a lovely cartoon in the New Yorker I saw a few years ago, which was in a veterinary surgeon's waiting room, and there were people with their pet dogs with their lampshades on and things, and the nurse was coming out, and she was saying to one of the people sitting there, "About your cat, Mr. Schrödinger, I have some good news and some bad news." Anyway, David Deutsch believes in the many worlds interpretation, which is that the cat is alive in some worlds and dead in others. Well, now that is, at least that doesn't totally defy common sense. It does defy economy. It's a ridiculously uneconomic idea.
Unparsimonious
idea. But unlike the Copenhagen interpretation, it's not just horrible.
Alarm! Imagine this. You're saying the theory of evolution by natural selection, it needs this amount of generations. And you say that, there are so many epochs and so many phases of evolution and blah, blah, blah. Like, isn't the amount of stuff that the theory needs so large? It is not parsimonious. Obviously, this is wrong. Why is this wrong? Because it is, roughly speaking, the amount of software that I need to write in order to implement the theory that is closer to the notion of parsimonious that we should use in order to judge a theory. It's not the count of the amount of entities needed in the theory. It is the complexity of the design of what the theory says, what I would call the algorithmic structure of a theory. Others would say the amount of equations that you need to write. So there's one easy way to see what I mean. That is, the content level of a theory is roughly the same thing as the memory usage of the algorithm when it runs on a computer. The memory usage of natural selection is very large because there are large amounts of time, large amounts of individuals, large amounts of genes, and large amounts of species, and so forth. You get the idea. The theory itself is very, very, very small. It is only 3 lines of code. The algorithmic structure is parsimonious, and we should judge a theory by its algorithmic structure. You can also say the amount of equations. This is the case for the multiverse theory. The universes are not enumerated in the theory. The algorithm of the theory is very simple. As far as I understand, it's the simplest. And this is how you need to judge a theory, whether it is parsimonious or not. So I hope I have disabused you of the dirty notion that multiverse is not parsimonious.